Hey guys, it's Ron. This is Lab 12, which covers switches. So this is our first break from routers, and we're going to take it kind of slow. I just want you to understand out of this lab the basics of switching. You know, how does a switch handle these various packets? How do hosts send packets when they're on their local subnet? Or how does a host send a packet when it's not on its local subnet? Now, what we're not going to dig into on this lab is all the background architecture that's going on. The sub interfaces, the VLANs, the trunks, spanning tree, all that kind of stuff that happens in the background. We're not really going to cover that during this lab. This is just so that you kind of get a feel for that layer 2 and layer 3 information and how it's used in this switching environment. So I'm going to fire up simulation mode, and I'm going to start out by just talking in my local subnet. So this, in my case, this is VLAN 2, but I just want to see how things act in this local subnet. So if I bring up my my PC, if I do an ARP-A, so I'm looking at my ARP table. And so this guy does not know how to get to anyone. It doesn't have anything in its ARP table. So if I try to go anywhere, it's going to end up ARPing. And if I look at my switch, and I do a show MAC address table, it really doesn't know about anything either. So 5 alpha and 4 alpha and 4 bravo 7 8 are attached to it, but it doesn't have their MACs because it's never received a packet with a source MAC address of any of these devices. All right. So until it gets a packet from them with that source address, it's not going to know where to go. All right. So if I bring my guy up, and I do a ping 172.16.1.3. So I'm pinging from host to host on my local subnet. It first does an ARP. All right. So I generate an ARP packet. An ARP packet, I'm using a source IP address of myself. I'm using a destination IP address of the guy I'm trying to ping. I have a source MAC address of myself and a destination MAC address of all Fs, which is a broadcast. So basically, I'm broadcasting out to find out the MAC address of this host. Okay? So I send it out. This switch receives it. And if we look here now, I've got an entry for 5 alpha, 4 alpha. Because now I've received a packet with that source address, or that source MAC address. So now every time this switch receives a packet for destination 5 alpha, 4 alpha, it's going to send it directly to him. Okay, because it knows exactly where he's at. So instead of instead of sending it out every other port, it can now do that filtering. Well, it continues to send this out, the original ARP request out every interface, and that's because it's a broadcast. So when it receives a broadcast, it sends it out every port. So you're going to see this packet go out every port. Now, this host has received it. It's going to look at it and say, you know what? That's my IP, and it's going to respond. All right? So these guys continue the broadcast. My host responds. It now says, okay, yep, that's my IP. I'm going to use my source MAC address, and I'm going to send it to destination 1.2 IP. All right? So when this guy receives it, it's going to say, 1.3 is this MAC address. Okay? Now this switch has also learned about that MAC address. All right? So now we have 4 bravo 7 8. So now I can apply filtering. The next time I have a packet for Bravo 78, I know exactly where to send it. All right. So if we continue this on, I've now learned about his MAC address. All right. If we close this out, bring this up, and I do an ARP-A, I've learned about, because I got a packet from 1.2, I now know his MAC address table, or his MAC address. So now I can send things directly to him. The switch knows about both of them, so it can send traffic in between them. So what you should see is this packet is just going to bounce back and forth, back and forth, back and forth. So I'm sending ARPs, or I'm not sending ARPs, I'm sending ICMP pings, and this host is generating replies. So if I come up here, I should now see that I'm getting replies, which I am. Okay, so this conversation is just going to continue here. It'll never have to leave this local switch because because it's on this local subnet together. Their IPs are on the same subnet. They're just going to continue to talk back and forth. And in this packet, I'm going to continue to send. If I'm sending to 1.2, I'm going to use destination 1.2, and I'm going to use his MAC address. So destination MAC address is 5 alpha 4 alpha, and that's because we're in this local subnet, so we can talk directly. All right. So I'm going to reset the simulation. Now, what happens if I try to communicate with somebody outside of my subnet? All right. So 1.66 is who I'm going to try to hit, this server out here. Okay, so what happens then? So I'll bring up and I'll try to ping 1.66 now. All right, so 1.66 is not in my ARP table, so I generate an ARP request. All right, so if we look at the details here, notice that I use my source IP. A little hard to. Okay, there it is. So target IP is this 1.1. So what this computer did is it looked at its IP address and its subnet mask, and then compared that information to this destination IP, the 1.66, and determined that 1.66 is not in my subnet, right? It's in a different subnet completely. So what it does is it forwards that packet on, or this, in this case, this ARP request to its gateway, okay? And in this case, the gateway is this sub interface on the router, okay? So our switches here are all layer 2 devices. So I need a layer 3 device to bridge the gap between this subnet and the subnet that has my server. Okay? So I send a broadcast, all Fs, and I'm sending it to 172.16.1.1, destination 1.1. So this ARP request isn't an ARP request for 1.66. It's an ARP request for my gateway. So this is how I first figure out how to talk to my gateway. So this packet is going to go out until it finally hits my gateway. So as a broadcast, it's going to be forwarded out every port. Okay? The router is going to look at the packet and say, you know what? 1.1, that's me. I accept, and I'm going to generate a reply. So it generates a reply, and if I look at this ARP reply, it's going to IP 1.2, so I'm returning the packet to 1.2. I have my source MAC address. So this is how my host is going to learn about the MAC address to its gateway. So let's continue to step it on. Now, all of these uh, switches have received a packet at one point in time from this host, from that original broadcast. So they're going to just continue to send it on directly to him. They'll apply their filtering. So instead of sending it in this direction, it knows, okay, this host is in this direction. So it continues to send it on. All right. So now my host knows the MAC address of its gateway. Okay. And so now it generates the ICMP, the ping. All right. So if we look at that, the ping is for destination IP 16.1.66. So this is the server. So it's sending destination IP of the server. However, if we look at the destination MAC address, the destination MAC address is our gateway. All right? So we're going to keep that IP information of our server, right? Because that's who we're ultimately trying to get to. But because we can't talk outside of our local subnet, I use the MAC address of my gateway. So the packet will ultimately first go to our gateway. So if we step it on out, it goes from switch to switch until it hits our gateway. All right. The gateway looks at the layer 3 information and says, you know what? That's not my IP. The IP is down here. So what it does is it hands the packet from this gateway to this gateway. It's really from one sub interface to the next sub interface. And then this guy is going to forward it on, because this guy is on a local subnet to this server, and it forwards the packet on. So if we look here, it's kind of hard to tell. We're still using a target IP of 1.66. We're still using a source. Well, this time the source IP is 1.65. So the router ended up changing it. So it says it's coming from this guy. Well, if we look, this isn't the ICMP packet anymore. This is an ARP. So the ICMP went all the way up to the router to 1.1. 1.1 handed it to 1.65 to forward on. However, 1.65 didn't know the MAC address of 1.66 because it's never talked to him before. So it does its own ARP. And if we look, destination 1.65, we're sending out a broadcast from 7201, which is my sub interfaces. Or source IP 1.65. So that's basically my server's gateway. So if we watch it, it's going to be broadcast on just like switches normally do. It's going to hit the server. The server's going to accept it, generate a response, and again it's generating this response to the 1.66. So destination of 1.65. So it's using its gateway. It's passing along its MAC address. These switches have now learned about this MAC address by the broadcast that it sent. So it'll forward it directly to the router. Now that the router has learned about the MAC address of this guy, it accepts that packet because it was addressed to 1.65. And now I'm able to ping all the way across. Alright? So this is the ICMP from my host. And if we look at the packet, I'm using a destination IP of the server, source IP of my host, destination MAC address, it's hard to see it in that one. Oh, it's right there. I'm just blind. So destination MAC address of 7201. So even though I'm trying to talk directly to him, I always continue to use my gateway's MAC address. All right. Forwards on. Forwards on. And notice here that the IP address stayed the same. I'm still destination 1.66, source 1.2. So IP wise, nothing changed. I'm still sourcing 1.2, destination 1.66. But notice up here though, the source MAC address is my gateway. All right? Because I can't use my MAC address to talk to him directly, my gateway's MAC address gets used. But my IP continues to be used. All right? So we forward. Now notice here though, if I bring this guy up, command prompt, I do an ARP-A. I'm learning about 1.65. We're going to forward on. I'm going to look at him again. That's a little odd. Yeah, I think that's a mistaken packet tracer. But it now knows about 1.2, but it should have used the MAC address of my gateway, when it fills in its ARP table. But not a big deal. It's probably just a mistake in packet tracer. But if we notice, the response is to my IP, but to destination MAC address of the gateway. And so now when we talk, we will always talk through that layer 3 device. All right? So it's going to continue, and it's just going to keep bouncing back and forth. I'm going to each of the hosts is going to continue to use the IP address of whoever they're trying to talk to, but they're always going to use the MAC address of that gateway, because I can't talk directly to them without going through that other layer 3 device. All right? And that's how it's going to continue on until my ICMP packets are finished. So I hope I didn't confuse you too much. The main point to learn is that when we're on a local subnet to each other, we can use each other's MAC addresses. We can talk directly. When it hits a switch only looks at that MAC address. So if it doesn't know the MAC address of the destination, or if it doesn't have a MAC address entry, it's going to broadcast, or it's going to send that packet out every port. Now, we didn't see that too much because majority of the time these were broadcasts going across, which by default it's just going to send those out every port anyway. But the point is that once it gets a packet, it looks at that source MAC, it adds that MAC address to its MAC address table, and then it can start to apply filtering. And this is where we start to get efficiencies in the switch, in that it can direct traffic specifically to certain ports because it's already learned those MAC addresses are only on those ports, right? And now, so that works great for your local subnet. Once you try to leave your local subnet, you need a layer 3 device. And so in this case, the only layer 3 device that we have is our router. So we have these sub interfaces on there that act as gateways. And so we will continue to send packets to our gateway and allow our gateway to forward those on to the other subnet. but we're going to continue to use the original IP that we were trying to hit, just changing that MAC address to our gateway. Alright, so that's it. Hope you learned it. Thanks for watching.